morning, Algebra 1, periods 1, 6, and 7. You wouldn't believe this, it's Monday again. Yes, it's the 18th of May, and I want to show you something here real quick. You ready for this? All right, so here it is. It's the 18th of May. We have 2 full weeks of instruction left before finals week, that first week in June. So I've got 10 days to subject you to all kinds of wonderful quadratics and graphing square root functions and all that kind of neat stuff you're getting into the next chapter. But what I'd like to do today is I would like to share with you a semester test prep. I'm going to post a semester test prep out there, and it'll give you guys a little practice so we can use those 10 days to actually get ready. Okay? So what I'm going to do, I'm going to begin with a problem that's going to look something like this. All right, so Algebra 1, Semester 2, practice test. You will encounter a problem that is similar to this. All right? I'm going to give you 3 lines. In this case, I give you y is equal to 2x plus 10, y is equal to negative 2/3 x plus 10, and y is equal to negative 2. And what the directions are going to say, it'll say find the 3 vertices and the area of the triangle formed. Okay? Now, you have a number of ways you could approach this problem. Probably the best idea is to draw a sketch. Okay? Now, when you sketch this, you will note that one of the vertices is handed to you, and you should have picked that up when you read the equation of the lines. They both cross the y-axis intercept at 10 because they're all, well, even that third one is in slope-intercept form. So the first point of intersection is handed to you, okay? Now I made this real nice. I made the third line a horizontal line, y is equal to negative 2. So you could actually sketch this out, and if you were really careful, you could actually find the points of intersection by graphing. Now, what are the odds of me being that nice on your semester test? Not good at all, people. So it's the mechanics of the problem that I'm going to stress, all right? So you did this little sketch right here. Now this y is equal to negative 2. How nice. To find this point right here, if y is equal to negative 2, you take the 2 equations, and at this point, the y value is exactly the same. So I put a negative 2 in for y, and I solved it for x. And x is equal to negative 6. Well, I already know y is equal to negative 2, so that point of intersection is negative 6, negative 2. Then you come over here, and you say, hey, look, that's where these 2 lines meet. Where those 2 lines meet, the y value is exactly the same. In this case, it's negative 2. So I put a negative 2 in for y, and lo and behold, magic, the point of intersection is 18 comma negative 2. Okay? All right? So now I have my 3 points of intersection. Now the second part of the problem, it says, and the area of the triangle formed. Now the area of a triangle, and you're going to need to know this, folks, the area of a triangle is 1/2 the base times the height. So the base of this triangle, being that I gave you y is equal to negative 2, what a beautiful base that is. You just have to determine how far it is from that point to this point. Well, I could use the distance formula if I really wanted to, but I'm not going to because it's a flat line. It has no slope. I just need to know how far the x's are apart. So from negative 6 to 18, that is a distance of 24. 18 units on the right side is 0, 6 units on the left side is 0. Makes a total base of 24. And the height, nice. 10 down to the origin, and then 2 more. So the height of that is a total of 12. Okay? So 1/2, 12 times 24 is 144. So the area of that is 144 square units. So the question reads, find all the 3 vertices. You found it. 0, 10, 18, negative 2, negative 6, negative 2, and you found the area to be 144 square units using the area of a triangle, 1/2 base times height. Okay? Beautiful. All right, problem number 2. You're going to love this one. All right, I'm going to give you 2 parabolas, and then I'm going to say find the equation of the line in standard form through the vertexes. So basically, all you have to do is find both vertexes. Now you have 2 points, and given 2 points, you can find the equation of the line. And here's a quick little review on how to find the vertex of a parabola. Make sure you're in standard form, people, standard form. All right, identify your A and your B and that equation to find the axis of symmetry, because we all know that the vertex is on the axis of symmetry. X is equal to negative B all over 2A. Boom, X is equal to 6. All right, plug 6 back in, and you will find that Y is equal to 16. So there's vertex 1, 6, 16. Okay, now to find vertex 2, you've got that beautiful fraction parked out front. So A is a half, B is 12. Well, negative B over 2A. Oh, this is a killer, people. The opposite of a positive 12 is a negative 12, and 2 times a half is 1. So the axis of symmetry is X is equal to negative 12. Plug negative 12 in. Be careful here. Negative 12 squared is 144, and a half of 144 is 72. And negative 12 times positive 12 is negative 144 plus 64, and Y is equal to negative 8. So there's my 2 points, okay? I have vertex 1 and I have vertex 2. Now, I have 2 points. If you recall, to find the equation of the line given 2 points, the first thing thou shalt do is find the slope. Always, you gotta find the slope first, okay? If you label your data, it makes things so much easier. I labeled my data, x1, y1, x2, y2, and what that means is that 6 is the x value of my first point, and the 16 is the y value of my first point. The negative 12 is the first value, or the second value, and the negative 8 is my second y value. Okay, plug them in, y2 minus y1 over x2 minus x1. Please don't forget, it's the change in y over the change in x, all right? Negative 8 minus 16, negative 12 minus 6, reduce, slope 4/3. Now, you have 2 options. Either one of these options requires you to pick a point. I don't care which point you pick, the answer will be the same. I'm going to pick the first one. Now, you have 2 ways to do this. You can use the point slope, or you can crank it right into y is equal to mx plus b. I did both of them to show you that you will get exactly the same line. All right? So the equation of the line that goes through the 2 vertexes of the 2 given parabolas is y is equal to 4/3 x plus 8. Now, isn't that a fantastic problem? All right? Now, that's a little preview. That's 2 problems that I will undoubtedly provide you on your semester test. Now, will they be that pretty? Probably not. Okay? And I'll put some more out here for you. But let's start with those 2, and we'll work from there. All right. So that's a little couple practice problems for your semester test, and you will see a couple of those. Then I have to get some creative and think of ways to make them unique to each individual. And I think I've got a plan for that based on the first letter of your last name. All right, so chapter 9. You guys should be cranking on that, okay? Should be nearly done with that. You've got a couple of check for comprehensions out there. You got 3 of them out there right now. Please get those turned in. Get your, some kind of a chapter 9 test is kind of coming in the works too. Not sure how it's going to work. But anyway, that's what I got for you. So it's Monday. Basically, we're going to wrap up. We're going to get those check for comprehensions done. They're posted on Plan Book. So please, please, please get them in. I got them in a grade book. So, and remember, we still have 10 days left. 10 days, that's a lot of days left, all right? So don't give up yet. Okay, folks, keep cranking. That's all I got for you for right now. So, 18 May, coming at you from 308. I'm out.